Yeah. Good evening, everyone. Good evening. Good evening, everyone. Please let me know audio video okay or not. Please let me know audio video okay or not. Check one time audio video okay or not. Is it fine? Audio video is okay. Can we start? Can we start? Please let me know. Yeah, let's move then. Let's move. Yeah, in the last class, we done until here. In the last class, we done until here. Now let's go to next program. Let's go to next program. Madam. Example 3. 2 examples are completed. I think 2 or 3. Let's check. So it is a third example. Yeah, fourth example. Let's go to example 4. Let's go to example 4. Yeah, let me write the date today. Today I think date is 8/11/2024. Yeah, let's start example number 4. In the last class, I completed 3 problems. Now it is the fourth problem. Yeah, write down now. Main. Let's try this. Main for I is equal to 1, I less than or equal to n, I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z, right? Next one. For I is equal to 1, I less than or equal to n. So remember here, I, right? See this one, I plus is equal to 2. X is equal to y plus 2. Next one, for I is equal to 1, I less than or equal to n, I plus is equal to 10. X is equal to y plus z. And one more thing, for I is equal to 1, I less than or equal to n, I plus is equal to 27. X is equal to y plus z. Now find out what will be the time complexity of this program. Can you try this? What is the time complexity of this program? I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. I is equal to 1, I less than or equal to n, I plus is equal to 2, x is equal to y plus z. So like this. Yeah, good evening everyone. Yeah, please go ahead. What is the time complexity of this program? Try what will be the answer for this? Everyone try this. What is the answer of this? Everyone try. Sunny, can I give answer? Yeah, let me give answer. Let me give answer. And one more thing I want to say to all the people who are watching, right? GATE 2026-27 for GATE CSE, GATE DA, new batches are starting. Go to the exampreptool.com. From there you can subscribe or you can WhatsApp us. We are going to help you. Right? GATE 2026-27 people can happily go to the exampreptool.com. From there you can subscribe. Yeah, fine. So let me start the answer for this. Let me start the answer for this. I'm starting. So make sure everyone listen. Make sure everyone listen. I'm giving the answer. What is the time complexity of this problem? So this one, I think it is program. If you observe, it is the first statement, it is the second statement, it is the third statement, it is the fourth statement. Right? There are four statements are there. First statement, if you observe, see this one. It is started from 1. Every time you are incrementing 1. What is the meaning? I think first it will become 1, next 2, next 3, next 4, next 5, and so on again time. So this will run n time. But if you observe the second statement, first 1, next 3, because every time 2 incrementing, next 5, next 7, next 9, and so on until n. So remember, every time 2 incrementing. It is almost like only odd numbers. It became n by 2. 2 skipping, every time 2 skipping. So it will repeat almost like n by 2 times. But if you see the third statement, always 10 skipping, it became n by 10. If you see the last statement, always 27 skipping, n by 27. N by 27. Now, order of magnitude of every statement I done. Now let me write order of magnitude of total program. Order of magnitude of total program n by 2, n by 10, right? N by 27. So, and one more thing, if you see properly, n common, 1 plus 1 by 2, 1 by 10 plus 1 by 27. It became n into some constant, which is nothing but, right? That may be 5, that may be 6, whatever it is. So time complexity big O of n, you can neglect constant. N into some constant. That may be 10, that may be 27, that may be 100, whatever it is, constant. So time complexity of this program is big O of n. Time complexity of this program is big O of n. So remember 5n is the time complexity. You can write big O of n. Next one, 100n is the time complexity. You can write big O of n. Right? Suppose, right? 10,000 n. Then also you can write big O of n. So be careful. It's a nice problem, right? Please take care. Time complexity of this problem is big O of n. Omega, theta, right? We will see afterwards. Omega, theta also. Check if anyone having any small doubt also. Every statement order of magnitude find out. Right? Always 2 decrementing. Always 2 incrementing. N by 2. Always 10 incrementing. N by 10. Always 27 incrementing. N by 27. Right? This is the answer for this. Yeah, I hope everything is fine. We can move to the next problem. Anyone having any doubt, you can ask me. In the comment section, you can comment if you have any doubt. If you don't have any doubt, right? So please say, let's move to next problem. We will move to the next problem. If you don't have any problem, please say you don't have any problem. We will move to the next one. Yeah, n by 2 also can be written as n. So I will write that also. Suppose n by 5. Suppose n by 5. That is also can be written big O of n. Suppose n by 100. That is also can be written as big O of n. You can neglect constant. That is the meaning of this line. You can neglect constant. That is the meaning of this line. Check if anyone feels something not clear, let me know. If anyone says something is not clear, please let me know. Time complexity of this program, big O of n. It's a really nice problem. Please take care. Yeah. Let's move to fifth problem. Example 5. Mean for I is equal to 1, I less than or equal to, I less than n. Equal is not there, so don't worry that much about equal is there or not there. Don't worry. I less than n, I plus plus. I less than n, I plus plus. X is equal to y plus z. Next one, for I is equal to 1, I is equal to n, I greater than 1, I is equal to I minus 1. Above I is equal to I plus 1. I plus plus means what? I is equal to I plus 1. X is equal to y plus z. Yeah, if you want, you can keep equal also, no problem. Don't think much. See, plus 1 minus 1 cannot change the answer. Don't think much. Plus 1 minus 1 cannot change the answer. Don't think much. Next one, for For I is equal to 1, I less than or equal to n, I plus is equal to 25. X is equal to y plus z. Next one. For I is equal to n, I greater than or equal to 1, I minus is equal to 75. X is equal to y plus z. So find out what is the time complexity of this program. Go ahead. I is equal to 1, I less than or equal to n, I is equal to I plus 1. I is equal to n, I greater than or equal to 1, I is equal to I minus 1. I is equal to I minus 1. I is equal to 1, I less than or equal to n, I plus is equal to 25. I is equal to n, I greater than or equal to 1, I minus is equal to 25. Yeah. Can you try what is the answer of this problem? Can you try what is the answer of this problem? Check. Let's see how many people will give answer. Yeah, there is a one offer is going on, 41% discount is going on, right? Use the referral code, right? You can get it. Use this referral code, you can get it. Right? Those people who want to join, so use this referral code, you can get it. Yeah, let me try what is the answer for this. Let me try what is the answer for this. Let me try what is the answer for this one. Everyone listen. So it is the first statement, it is the second statement, it is a third statement, it is a fourth statement. There are four statements. So first statement order of magnitude, if you observe n, always plus 1. Second statement order of magnitude, if you see, this is also n. Remember, start from small number, always increment by 1. That is also n time. Start from big number, always decrement by 1. That is also n. The only thing is, one is increasing numbers, another one is decreasing numbers. Here if you see 1, 2, 3 and so on n. But here if you see n, n minus 1, n minus 2, and so on 1. Both are same number of time. First loop also n time, second loop also n time. One is going from small to big, another one is going from big to small. They both are same. I want to say that first statement, how many times I executing, second also same. You may say that, sir, that is plus, that is minus. Nothing there. Plus means start from small number, keep on increment. Second one, if you observe, start from bigger one, keep on decrement. Now see the third one. See the third one. Always incrementing by 25, n by 25. Always decrement by 75, n by 75. So remember everyone, here I started from small number, always incrementing by 25, n by 25. Here I started from big number, always decrementing by 75, so n by 75. I want to say that, right? Always incrementing by 25 or always decrementing by 25, both are same. I want to say that. If I don't say, you feel that minus is different. No, whatever plus doing, reverse minus doing. So suppose 50 plus 20, 70. 70 minus 20 is a 50. One is increasing, one is decreasing. So if you see these are the order of magnitude of every statement. Now see the order of magnitude of total program. Total program, if you observe, n plus n by 25 plus n by 75, which is going to be n common if you do. So these all will leads to some constant. So n into constant, n into some constant, whatever it may be. which is going to be big O of n, which is going to be big O of n. Let me know if anyone having any objection. Anyone having any objection, please let me know. Little doubt also there, you can ask me. Can we go further? Little doubt also there, you can ask me. Yeah, so can we go to next problem? Check everyone. Can we go to next problem? Yeah, let's move to next. Let's move to next. I think we done decent work. We done the decent work till now. Let's move to next problem. Let's move to the next problem. Yeah, next problem. Example, maybe I think sixth problem. Example number 6. Yeah, fine. Let's go to example number 6. Main. For I is equal to, careful. For I is equal to 1. I less than or equal to n. I is equal to 1. I less than or equal to n. I plus is equal to 2. X is equal to y plus z. In the similar way, for I is equal to n. I is equal to n. I greater than or equal to 1. I minus is equal to 2. X is equal to y plus z. For I is equal to 1. I less than or equal to n. I, see this one, see everyone. I into 2. Here I is equal to I into 2. X is equal to y plus 2. So y plus z. Now for I is equal to n. I greater than or equal to 1. I greater than or equal to 1. I divide is equal to 2. X is equal to y plus z. Yeah, continue this. I is equal to 1. I less than or equal to n. I plus is equal to 2. X is equal to y plus z. I is equal to n. I greater than or equal to 1. I minus is equal to 2. X is equal to y plus z. I is equal to 1. I less than or equal to n. I star is equal to 2. X is equal to y plus z. I is equal to n. I greater than or equal to 1. I divide is equal to 2. X is equal to y plus z. Can you go ahead to what is the answer for this? Try. This is a very nice problem. Let me check. This is a very nice problem. Yeah, try what is the answer of this problem. Yeah, what is the answer for this? Check everyone, what is the answer? So let me try one by one. It is the first statement, it is the second statement, it is the third statement, it is the fourth statement. There are four statements. If you see the first statement, always plus 2, n by 2. If you see the second statement, always minus 2, n by 2. Right? But see the third statement, everyone listen, third statement, always into 2. Everyone listen, always into 2. So remember it is log n base 2. Always divide by 2. That is also log n base 2. If you want, you can verify. Always by 2 or always into 2. Always become double. Double. Double means what? First you started with 1. Right? 1 into 2, 2. 2 becomes 4. 4 becomes 2 into 4, 8. 2 into 8, 16. So it is going in multiplication of 2. You count if you want, it is going log n time. So how it is? First n. Next n by 2. Next n by 2 square. Next n by 2 cube. It is also always divided by 2 by 2. Lastly 1. So both are same. One is incrementing, one is decrementing. It is decrementing. Both are similar. If you see in the reverse order, both are same. Both are same. So please be careful. From this problem, I want to explain. If you always multiply by 2, log n base 2. If you always divide by 2, log n base 2. So this is the order of magnitude of every statement. It is the order of magnitude of every statement. So if you see order, right, order of magnitude of every statement, what is the order of magnitude of total program? Right? N by 2 plus n by 2 plus log n base 2. Log n base 2. So remember everyone, in front of n, log n base 2 is very small. Small terms you can neglect. In front of n, log n base 2 is very small. You can neglect. So it will become 2n by 2. 2n by 2. Right? Constants you can neglect. It became big O of n. It became big O of n. Constants you can neglect. Smaller terms you can neglect. Constants you can neglect. Smaller terms you can neglect. Constants also you can neglect. Smaller terms also you can neglect. In front of n by 2, log n is very small. Neglect. In front of right. So that I think constant into n by 2. Constants you can neglect. So answer is big O of n. It's a nice problem. Please take care. It's a nice problem. Please take care. So this problem is nice. Yeah. Sunny, can we go to next problem? Sunny, can we go to next problem? Sunny, can we go to next problem? So remember everyone, remember everyone, remember everyone. So 2026 batch is starting, 2026 batch is starting, 2027 also starting. Syllabus will be over within 6 to 8 months. 6 to 8 months syllabus will be over. 6 to 8 months syllabus will be completed. Remaining time approximately 6 to 8 months. Remaining time. You can do practice. You can do practice. And one more thing is 6 to 8 months syllabus will be completed. Remaining 6 to 8 months practice also will be done. Test series also will be available. Test series also available. Approximately 100 plus tests are there. And one more, rank improvement course also available freely. Rank improvement course. And 24/7 doubt solving also there. 24/7 doubt solving also there. So you can go to exampreptool.com. From there you can subscribe. From there you can subscribe. You can use code EPT 595 capital ARJ. You will get the discount also. You will get the discount also. Right? GATE 2026, GATE 2027. GATE 2026, GATE 2027. Right? So first to 6 to 8 months syllabus will be completed. Next to 6 to 8 months practice will be there. And one more thing is the test series also there. One more thing is rank improvement course also there. 24/7 doubt solving also there. Right? We will provide AIR1 notes also. We will provide AIR1 notes also. We will provide AIR1 notes also. Yeah, let me know if anyone having any doubt. Yeah, fine. Let's move to next problem. Let's move to next problem. I think example number 5 is completed, 5 or 6. 6 is completed. Example number 6 is completed. Go to example number 7. Go to example number 7. I'm writing here 7. Example 7. Example 7. Main. Example 7. Main. For I is equal to n. For I is equal to n. I greater than or equal to 1. Right? I greater than or equal to 1. Next, let me write now. I is equal to I minus n by 2. X is equal to y plus z. For I is equal to n, otherwise let me write here. I is equal to 1. I less than or equal to n. I is equal to I plus n by 4. X is equal to y plus z. I is equal to 1, I less than I greater than or equal to 1, I is equal to I minus n by 2. I is equal to 1, I less than or equal to n, I is equal to I plus n by 4. Can you try once? What is the answer of this? Let's see how many people will give. If you start from big number, subtract. If you start from small number, but right, if you start from small number, add. Start from big number, then you have to subtract. Start from small number, then you have to add. Already, suppose assume that already starting with big number, you cannot add because is already big. Right? If you start from small number, you have to add because is already small. You have to add. Let's see how many people will give answer for this. First of all, two statements are there. First of all, there are two statements. First statement, second statement. First statement is how many times check. Second statement is how many times verify. First statement is how many times. Second statement is how many times. Please verify yourself. Please verify yourself. Sunny, please verify. First statement is how many times. Second statement is how many times. Please verify. Yeah, try anyone. Can anyone give answer? What is the answer of this? Now I want to explain everyone. It's very simple. So please don't do every time blindly. Please don't do every time blindly. Yeah. Please don't do every time blindly. My sincere request is please don't do every time blindly. That is the reason I given this problem. Let me check once. Let me check. Let us assume that n value 20. Assume. If n value 20, first to 20 greater than or equal to 1 condition true. Next time 20 minus n value 20. So 20 minus 20 by 2, 10 subtracted. So it became remaining is 10 only. Right? Next round 10 is greater than or equal to 1 condition true. Condition true. Right? So first to 20 greater than or equal to 1 condition true. Right? Next one, second time, I value is 20 minus 10, 10. Now I value became 10, 10 greater than or equal to 1. That is also condition true. Right? Next time, right? Now I value becomes 10, 10 minus, right? So 10. Remember, I is updating, n is not updating. I is updating, n is not updating. So I right, n value is still 20, 20 by 2 is 10. 10 minus 10 is 0. So 0 greater than or equal to 1 condition is failed. So remember everyone. So right, first to 20 it will work out. Next to 10 it will work out. right? Next to 20, it will first 20 worked out, 10 worked out, 0 it don't work out. So first loop is 2 times. First loop is 2 times. Now can you see this one? Let us assume that in the right. Let us assume n value is. Let us assume that n value 20. Now see the answer. N value 20. First one. I value 20. Sorry, I value 1. Assume that n value 20. So I value initially 1. 1 is less than or equal to 20. Condition true. Then what he is doing is I is equal to 1 plus 20 by 4. 20 by 4. I think 5. So it will become 6. Next round 6 less than or equal to 20, condition true. Next one 6 plus 5, which is going to be 11. That is also true. 11 less than or equal to 20, condition true. Next 11 plus 20 by 4 means 5, which is going to be 16. That is also true. 16 less than or equal to 20, that is also true. Next one 16 plus 5, 21. 21 less than or equal to 20, condition failed. So if you observe clearly, only 4 times going on. So second loop is only 4 times. Second loop is only 4 times. First loop is only 2 times. So order of magnitude of every statement you done. So if you see the order of magnitude of total program, it became 6. It will become big O of 1. Time complexity of this program, big O of 1. Time complexity of this program, big O of 1. So please use common sense. Don't do blindly. Please use common sense. Don't do blindly. Array, see this one. Always you are subtracting n by 2 yeah. If you write n contain 2 n by 2s. N contain 2 n by 2s. From the n, always if you subtract n by 2, only 2 times you can subtract. Next one, n contain 4 n by 4s. Always if you keep on adding n by 4, n by 4, n by 4, after 4 times it became n. Afterwards it will fail only. So what I mean to say is please check properly. Please check properly. See, n contain 4 n by 4s. It will execute only 4 times. Right? Next one. N contain 2 n by 2s. It will go only 2 times. Don't go blindly. Don't go blindly like this one. See this one. Here there is some logic. Always by 2. Always by 2. Remember. Always by 2. Right? Log n base 2. Always into 2. Log n base 2. Always minus 2 n by 2. Always plus 2 n by 2. Right? Remember, they are the standard things. If you want, you can try proof also. If you try this one, you will get the proof also. See this one. One geometric, right? See this one. 1, 2, 4, 8. I think one GP series going on. You solve it, you will get the same answer log n. Here also one GP series going on. You solve this, you will get the log n. Here also you will get the one AP series. Right? Here always subtract, always adding to. One AP series will come. So I think first one 1, next one 3, next one 5, next one 7, next one 9. One AP series going on. You solve it, you will get the same answer n by 2. Here also one AP series n. Next one is 2 to subtract n minus 2, n minus 4, and so on. Lastly 1. Here also one AP series. You solve this AP series, sum of all the terms in the AP series, you find out, you will get n by 2. It is also n by 2. Now this GP series you solve, you will get log n. This GP series also you solve, it will also become log n. Do these proofs also possible. If you want, you can verify. Right? But here it is a common sense. It is a common sense. One n contain 2 n by 2s. If you subtract always n by 2, 2 times only you can subtract. One n contain 4 n by 4s. If you subtract, right? If you add always n by 4, n by 4, n by 4, after doing 4 times, it became n. Further, it will fail anyhow. So time complexity of this program is constant. Every constant can be written as big O of 1. Remember, every constant can be written as big O of 1. This is the way of writing constant. In algorithm terminology, writing constant is like this, big O of 1. In algorithm terminology, writing constant, any constant you can write. Suppose 100 is a constant, you can write like this, big O of 1. Suppose 5 is a constant. You can write like this one, big O of 1. Suppose 20,000 is a constant. Every constant can be written as big O of 1. Every constant can be written as big O of 1. In algorithm terminology, every constant is same. In algorithm terminology, every constant is same. If you think this program time complexity constant, simply write big O of 1. Simply write big O of 1. I hope everyone is comfortable. Let's move to one more problem. Example, I think 7 over, I think 8. Example 8. Example 8. Example 8. Main for I is equal to main for I is equal to 1. I less than or equal to n. I into is equal to 7. Always multiplying by 7. Always multiplying by 7. Next one, for I is equal to 1. I less than or equal to n square. I into 7. X is equal to y plus z. For I is equal to n square. I greater than or equal to 1. I divide is equal to 7. X is equal to y plus z. Next one, I is equal to for I is equal to 1. I less than or equal to n square. Let me write one small line. For I is equal to n power 7. I greater than or equal to 1. I divide is equal to 9. X is equal to y plus z. End of the program. Can you try this? What is the answer of this? What is the time complexity of this program? It is the example number 8. It is the example number 8. Can you check this? First of all, identify how many statements. Please go to every statement. Please verify how many times that loop is going on. Go to every statement. Please verify how many times that statement is executing. Right? Let's see how many people will give answer. What is the time complexity of this program? Every statement order of magnitude find out. Every statement order of magnitude find out. Yeah. Can I give answer? Yeah. Let me try answer. Let me try. Most probably your answer is right. Let me give answer. See, first statement order of magnitude. Try properly. Always multiplying by 7. Log n base 7. Check properly. Always multiplying by 7. Log n base 7. Now listen. Now listen this one. This also always multiplying by 7. Listen. This also always multiplying by 7. It is also log n base 7. Remember, n there log n base 7. N square there log n square base 7. Whatever there, that one. If n is there, log n base 7. N square there, log n square base 7. Now, what about this one? What about this one? What about this one? Let me check. Log n square base 7. What about this one? Same thing. Always divide by 7. If at all always divide by 7, log n base 7. If at all n there, but n place n square there, log n square base 7. It is also same, always by 9. This is also log n base 9. If n is there, n place n power 7 there, n power 7. Always divide by 9, right? Log n base 9 if n there. If n power 7 there, log n power 7 base 9. Always divide by 7, log n base 7 if n there, but n place n square there, keep n square. So careful everyone. Now some people are asking, sir, this can be written as this one. This can be written as log n base 7. This can be written as 2 log n base 7. This can be written as same 2 log n base 7. This can be written as 7 log n base 9. Add all of them. Add all of them. First one is log n base 7. Second one is 2. Let me write now. Log n base 7 plus 2 log n base 7 plus 2 log n base 7 plus 7 log n base 9. So forget about all the constants and all. Constant cannot affect anything. Answer is big O of log n. Forget about base, whatever it may be the base. Right? All bases are differ by constant. All bases are differ by constant. So the answer of this one, log n, that's it. The answer of this one, log n. The answer of this one is big O of log n. Don't worry about the base. Don't worry about the base. Right? Don't worry about the base. Answer is big O of log n. Answer is big O of log n. Anyone having small doubt also, some small twist I kept in this problem. In this problem, I kept a small twist. In this problem, I kept a small twist. In this problem, I kept a small twist. N place, I kept n square. N place, I kept n square. Log n square base 7, which is going to be 2 log n. Log n square base 7, which is going to be 2 log n. Log n power 7 base 9. 7 will come left hand side. 7 log n base 9. So this is the final answer. Let me know if anyone having any doubt. So Sunny, are you okay? Sunny, do you have any doubt? Sunny, do you have any doubt? Yeah, let's move to one more problem. Example number 8 over, example number 9 you see. Example number 9. Main Example number 9, main. For I is equal to 2, I less than or equal to, I is equal to 2, I less than or equal to n, I into is equal to 2, x is equal to y plus z. For I is equal to 70, I less than or equal to n, I into, right, I into is equal to 4, x is equal to y plus z. For I is equal to, for I is equal to 89, I less than or equal to n power 20, I star is equal to, I star is equal to 13, x is equal to y plus z. Yeah, can anyone help me? What will be the answer of this? It's a very interesting problem. Let's check. It's a very interesting problem. Let's see how many people will give answer. It's a very tricky. It's a very tricky problem. It's a very tricky. Let's see how many people will give. Yeah, let's see the story. Let's see the story once. Let's see the story once. This is going, I think, always, right, by 2, always into 2, always into 2. See this one, always into 2. It is going to be log n base 2. Listen, log n base 2. You may say that, sir, this is going to be log n base 2 if you start from 1. If you start from 1, then log n base 2. Sir, you started from 2. I think a few terms are missing. Actually, you have to start from 1. Because of I started from 2, few terms are missing, no problem at all. If you want, you can subtract minus 2, no problem. If you start from 1, if you start from 1, if you start from 1, then log n base 2. Because of you started from 2, few terms are missing. So missing terms, if you want, you can subtract. Right? So I think some people are asking, missing terms are from where to where I missed out. So 1 to 2 I missed out. If you start from 1 to 2, you missed out. I think 1 to 2, how many times? Because of always multiplying by 2, log 2 base 2, nothing there. If anyone is not getting, you may get more clarity here. Can you see this one? If you always multiply by 4, everyone listen. If you always multiply by 4, log n base 4, that is okay. But remember, if you start from 1, log n base 4, because of you started from 70, so what is the meaning? 1 to 70 you missed out. Right? Larger number is what? 70. If you want, you can do log 70 base 4. Because some terms are you missed out. If you start from 1, log n base 4, because of you started from 70, 1 to 70 you missed out. 1 to 70, how many times? That is also log only, but log 70 base 4. So if you, because of anyhow, log 70 base 4 constant, you can neglect. Anyhow, log 2 base 2 is a constant, log 2 base 2 is one constant, you can neglect, no problem. Next one. Can you come here? Can you come here? Always multiplying by 13 log n base 13. Listen, log n base 13 if n is there, but n power 20 there. N power 20. Log n base 13 if n is there, n power 20 there, keep n power 20. But remember, if you start from 1, that is the story. But you started from 89. What do you mean? 1 to 89 you missed out. 1 to 89. What is the answer? Because of always multiplying by 13, same effect. Log 89 base 13. But anyhow, log 89 base 13 is a constant. You can neglect. So finally, if you see the total story, right? So order of magnitude of total program, log n base 2 plus log n base 4 plus 20 log n base 13. Forget about constants. If you see bigger term log n, answer is big O of log n. Answer is big O of log n. You no need to bother. You no need to bother. What is the base? You no need to bother what is the base. It is the ninth problem. It is the ninth problem. Answer is log n. So today, excellent class happened. Today's class is extraordinary. Today's class is extraordinary class. Remember, today's class is started from here. Today's class is started from here. It's an excellent class. Today's class is excellent. You please go through it all of them one time. Sometimes I will plan something. It may not happen. Today, everything happened whatever way I felt. Today, everything happened whatever way I felt. So this is the excellent class. You please go through it. One small doubt also there, please ask me. One small doubt also there, please ask me. One small doubt also there, please ask me. Little doubt also there, please ask me. One small doubt also, please ask me. So it is the ninth problem. I think this is the ninth problem. Sunny, do you have any doubt? Anyone having any doubt, please let me know. Anyone having any doubt, please let me know. The answer of the ninth problem is log n. Guruji. Yeah, if you have any doubt, let me know. Sunny, if you have any doubt, let me know. Those people who are preparing for GATE 2026, 27 people. 26 people, 27 people. GATE CSE or GATE DA. CSE or DA. Happily you can join this batch. Happily. What is this? Guruji. Yeah, let me know if any doubt. Yeah, so if you are preparing for GATE CSE or GATE DA for 2026 and 2027, happily you can join this batch. Come on, let's make it. Yeah, so the doubt regarding whether the conditions inside the for loop parameters are considered statement or not. Yeah, if you consider also, Sunny, if you consider also 5n assume, 5n becomes n only. If you want, you can consider. So I will explain that. I will explain your point. Right, actually not required because of you are asking. This is the correct time to explain. This is the correct time to explain. Can you see this? Main for I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. This is a program, right? As I mentioned to you, only one statement. If only one statement is there, order of magnitude is n. Suppose you want to consider other people also, right? This one, right? This is A, this is B, this is C, this is D. If you observe clearly, out of this total program, see this one. First one, A will execute one time. B will execute approximately n plus 1 time, because the last fail also will come. See, I value incrementing by 1, by 1, by 1, by 1. Lastly, n plus 1. N plus 1 less than or equal to n. Condition fail, you come out. B value n plus 1. Right? If you see C, n. If you see the D, which is n. Right? Totally 4 people. Right? A is 1 time only, B is n plus 1, C is n, C will execute n time, D will be n time. Incrementation is n time. Right? So incrementation, if you see, 1 will increment, 2 increment, and so on, n will increment. 1 to n. So if you observe clearly, all of them, if you add also, n plus 1 plus 1, which will goes to 3n plus 2, which is nothing but big O of n. Which is nothing but big O of n. Is it okay? At the end of the day, same answer. At the end of the day, same answer. Even though if you consider answer n only. Even though you consider final answer is same only. Fine? Am I right or wrong? Even though if you consider inside people, same answer. Same answer. It's a wastage of time. So next time onwards, you no need to consider A, you no need to consider, right? You no need to consider B, you no need to consider D. Sir, we apply big O only at the end after calculating the order of magnitude of the while program. Yeah, you can calculate anywhere, but normally we will do at the end. In further classes, you will see that. You can apply anywhere. It's up to you. Normally, we will do at the end. Lastly, see, you no need to give approximation every time. Give approximation last. Don't do approximation every time. Do approximation at the last. Final conclusion, say approximately. Don't say approximation every time. Don't say approximation. Don't do approximation every time. Do approximation at the end. Right? It is not a good idea doing approximation every time. Do approximation at the end. At the end, approximately n, there is a meaning. Every time you cannot do approximation. If you want, you can do, but it is not desirable. Right? So do approximation at the end. Nice question. Thank you. Thank you so much, Sunny. You asked excellent questions. You asked excellent questions. Keep asking. Keep asking in the similar way. Keep asking in the similar way. You are asking excellent questions. Keep asking similarly. Yeah. We will meet in the next class. Thank you so much. We'll see in the next class. Today's class happened nicely, right? So we'll see with some more problem in tomorrow's class. Right? Fine. Thanks everyone. This is the code you people can use. You will get the code, right? Very good discount you will get. Thanks everyone. Good night. See you in the next class.